Welcome back on the lecture series of topic Introduction to Analytical Chemistry. So today we are going to study mathematical operation and error analysis. In the quantitative conclusion, we obtain numerical data by experimental method. On the numerical data, mathematical operation taking place and we express quantitative error accuracy measurements. Scientific notation or exponential notation. In this notation, every number can be denoted into a form n into 10 raised to n, where small n is the exponent having positive or negative values and capital N is any number in between 1 to 10. For example, the number 1203.546 becomes 1.2356 into 10 raised to 2. Here decimal point moves to left by 2 places. That's why we take 10 raised to 2. Here 0.00015 is equal to 1.5 into 10 raised to minus 4. Why we take 10 raised to minus 4? Because decimal point moved to right by 4 places. Now we see about the addition and subtraction operation. For example, 5.55 into 10 raised to 4 and 6.95 into 10 raised to 3. So step 1 is equalize the exponents. So you have to equalize it. So 5.55 into 10 raised to 4 plus 0.695 into 10 raised to 4. Then the answer it comes 6.245 into 10 raised to 4. Now we see about the subtraction of operation. For example, we take 3.5 into 10 raised to minus 2 and 5.8 into 10 raised to minus 3. Again, step 1 is to equalize the exponents. So 3.5 into 10 raised to minus 2 minus here 5.8 into 10 raised to minus 3. So you have to take 0.58 into 10 raised to minus 2. So answer it comes out to be 2.92 into 10 raised to minus 2. Now we see about the multiplication. So we take again one example. 5.6 into 10 raised to 5 into 6.9 into 10 raised to 8. So here you know the basic rule in mathematics. When the multiplication we carried, then the exponents must be added. Okay, so 5.6 into 6.9 into this 5 and this 8, 5 plus 8, so it becomes 13. So 38.64 into 10 raised to 13 we get, and convert it into 10 raised to 14 by 3.864 into 10 raised to 14. Now we see about mean values. A mean value is obtained by dividing the sum of a set of replicate measurements. Replicate means repeated measurements. Replicate means repeated measurements by the number of individual results in the set. For example, if titration is repeated 4 times and the titer values are 10.1, 9.9, 10 and 10.2 ml, then you have to take mean in such a way you have to sum up these all readings, that is 10.1 plus 9.9 into 10 plus 10.2 and divide by 4. Why we take 4? Because 4 readings are there, that's why we take 4 here. So the answer comes out to be 40.2 upon 4. It comes out to be 10.05. So this is all about the mean value. This mean value is also called arithmetic mean or average. Now we see about the median. This is a value about which all other values in a set are equally distributed. Half of the values are greater and the other half smaller numerically compared to the median. For example, if we have a set of values like 1.1, 1.1, 1.2, 1.3, 1.4 and 1.5. The median value is 1.3. When a set of data has an even number of values, then the median is the average of the middle pair. This rule is for the even numbers. Now we see about the accuracy. Accuracy means nearness of measured values to the true value is called accuracy of measurement. Larger the accuracy, smaller is the error. Any difference between the measured values and expected values is expressed as error. For example, the dissociation constant for acetic acid is 1.85 into 10 raised to minus 4 at 25 degrees centigrade. In an experiment, if a student arrives at exactly this value, his value is said to be accurate. Now we see about the relative error. So how we calculate it? By taking the ratio of absolute error to the true value and multiply it 100%. Now we see about the absolute error. Absolute error can be calculated by observed value minus true value. Least count. What is least count? The smallest value that can be measured by the measuring instrument is called the least count. Now we see about true or accepted values. Aim of any measurement is to get the actual value called the true value. Precision. In precision, the closeness of the two or more quantities to each other is called as the precision. Taking multiple readings of same quantity to minimize the error. Reading match closing that reading is called high precision. It is expressed in terms of deviation. So, however, a precise value need not be accurate. There are the two types of deviation. Absolute deviation, it is defined as modulus of the difference between an observed value and arithmetic mean for the set of several measurements. That is, concisely we say like that absolute deviation is equal to modulus of the subtraction of the observed value and mean. Now we see about mean absolute deviation. It is defined as arithmetic mean of all the absolute deviation. Relative deviation, it is calculated by mean absolute deviation upon mean into 100. Accuracy and precision concept. What is the main difference between accuracy and precision? Precision concept. So we take the example. Suppose the true value for here ball is there, not boy. Okay, here ball is there. For a ball is 5 gram and Ria takes two measurements, 4.93 gram and 4.95 gram. So the result for the same ball 5 gram is accurate mass. That is 4.93 and 4.95 are precise but not accurate. So this is all about accuracy and precision. Thank you.